Sounds fun.
I know, I'm not talking to her.
Yeah, she's gonna talk.
I'm not.
She's gonna talk much. Challenge?
All right.
Not eating.
Are we ready to get started? This is the end of week 9. This is the end of week 9. Let's all look at people walking in late. We say that to camera. So we have quiz. So here's the deal. Are you ready? Write this down. See a quiz 3 on November 12th and 14th. The quiz is on the 14th. We're not going to have class on the 12th. We're going to take a vacation. Wait, am I recording this? Damn. So the quiz will be on the 14th of week 10. But next week we have Tuesday and Thursday. Then we'll have Tuesday off the 12th, and then the quiz will be on the 14th. Everybody got it? All right. I'll probably say it every class between now and then, because I don't want anybody to show up and us not be here. Oh, that's a costume?
Yeah.
Oh. Wow. I thought wearing orange was like a costume. So, what are we doing? What are we doing? These are the 5 different types of 2 sample hypothesis testings we've done and going to do between now and the quiz 3. These are the 5 that are going to be on the quiz. There they are. Independent sample using Z, independent samples using T, but assume that the variances, population variances are equal. Independent samples using T, assume unequal population variances. And then there's related samples. That was all this week has been related samples. We're finishing that today using T. And then proportions next week using Z. Those are the 5. I'm going to read a problem, and you got to tell me which of these 5 it is, because that's going to be the hardest part about quiz 3. Once you realize which one of these 5 to use, you know the formulas. They all have slight differences. Find the test statistic. They all have slight differences to find the confidence interval. But basically, in general, it's all the same. And the Excels, once you get your test statistic, and once you get your critical value, or you know your significance, you can get your critical value, you can do any of these. So, here's the first one. Here's the first one. It's one of these 5. A manager of an industrial plant asserts that workers on average do not complete a job using method A in the same amount of time as they would using method B. 7 workers are randomly selected. Each worker's completion time in minutes is recorded by the use of method A and then method B. The observation generates the following results. The mean difference is 3.3 minutes, and the sample standard deviation of the difference is equal to 2.8. To make this easy, is it 1, 2, 3, 4, 5?
4.
Is it 1? Go from the top. 1, 2, 3, 4, 5 so far. I've heard a T and 1 number. There's I know the camera can't see, but there's like 30 some people in here not saying a word. Gee, what if this were the quiz today? You can't just stare at it forever. You got to figure this out. Why did you say 4? Who said 4? Yeah, why?
Because there's a mean difference.
There is a mean difference. Very good. That's a key word, but that wasn't as much of a giveaway as
Method A.
Sample standard.
method A and B, but they're using the same sample. It's the same, how many? 7, 8, 7 workers. It's the 7 workers before and the 7 workers doing the other thing. One and the other, but the same 7, the same sample. They're related. They're just changing the process is all. So that's why it's number 4, related samples, what we learned this week. You guys are scaring me. I don't know if I should continue. It's going to be embarrassing if anybody watches this. All right, let's go. I can't believe we're taking a risk. A design engineer at Sterling Manufacturing, a supplier of high-quality ball bearings, claims a new machine process can result. This is tricky. This one's a little tricky, so let me keep going. A machine process that results in a higher daily output rate. Higher daily output rate would be how many, I guess, per day being made, ready to be shipped. Accordingly, the production group is conducting an experiment to determine if the claim can be substantiated, that the production rate can be increased. I should be asking you if this is one tail or two tail at this point. That the production rate can be increased, one tail or two tail, huh? It is one, increase was the key word. Well, hang on. Accordingly, the production group conducting experiments determined if the claim can be substantiated. The mean and the standard deviation of bearing in a sample of 8 days output using the new process equals 2013.63 and 90.78 respectively. Do you want me to read that sentence again? The mean and the standard deviation of bearings in a sample of 8 days, so they counted how many out of 8 random days or whatever it is, using the new process is 2,613.63 per day with a standard deviation of 90.78. A similar sample of 10-day output from the old process yields a mean and standard deviation of 2,485.10 and 148.22 respectively. We can assume that the population variances of the two products are equal. Oh boy, 1, 2, 3, 4, 5. It is 2, but was it the last sentence that gave away? Were you suspicious whether it was 2 until that last sentence?
Yes.
It's the last sentence that gave it away, wasn't it?
Either 2 or 3
Until the last sentence, 2 or 3 until the last sentence. And then hearing the words, we can assume that the population variances of the two products are equal, boom, fits right into this one. Independent samples where you would be using a T, and it happens to be assumed equal variances. So there you go. I heard a lot of you, so that one went well. Let's try this one. Now don't get me wrong, this could be a repeat. I want you to know all 5 are open here. It's not like 2 are out of the way now. These can repeat. Despite his inexperience, candidate A appears to have gained support among voters. 3 months ago, in a survey of 120 registered voters, 55 said they would vote for candidate A. Today, 41 registered voters in a sample of 80 said they'll vote for candidate A. Construct a 95% confidence interval to determine if the null hypothesis can be rejected or not. 1, 2, 3, 4, or 5. Oh, dead silence, folks. Dead silence. Is this?
5.
Who's gonna vote?
5.
5 it is. 5 it is. The only thing that you have to do with this is you got to convert it to the proportions by how many out of how many. You got 2 samples there. One sample was size, 55 out of 120. Sample size 120, 55 said they'd vote. So 55 divided by 120 is your one proportion, which we're going to learn next week, by the way, but I thought you'd for sure recognize this since we had proportions already in 2 different quizzes. And then the other sample size is 80, 41 out of 80. 41 divided by 80 would give you your other proportion. And then next week you're going to learn what to do with those 2 sample proportions. But that was number 5, you're right. I think will it be easy to recognize number 5? I mean, after you guys had a minute and realized what was going on, a lot of you said 5 pretty fast, but there was dead silence to start with. You think you can recognize proportions? Can we just skip next week? Oh, good job. For those who came in late, by the way, when's our vacation? The 12th. We're on vacation the 12th. Write that down. You're on vacation the 12th.
What do you got planned?
What? You're welcome?
What do you got planned?
I don't have any plans. Grade your stuff. Stuff. Get that? Yeah, but the grader doesn't grade the in-class assignments or the quizzes. And I gotta write the new quiz. I gotta write that because it's different every semester. According to Health of Boston report, female residents in Boston have a higher average life expectancy than compared to the male residents. You collect the following sample data to verify the results of the report. You also use historic population standard deviation of 8.2 years for females and 8.6 years for males. Females mean is 82.1, males mean is 76.2. The number of females is 32, the number of males is 34. 1, 2, 3, 4, 5.
1.
You just saying it because you heard it?
No.
Okay, why then?
Because it's the population standard.
There it is. Very good. Nice. It's all over that. The population standard deviation kind of gave that one away, so you'd be using 1, which is Z, and they're not related in any way either. These are independent samples. They're not related. One was females, one was males, life expectancy. So that also kind of gave it away. It was number 1 also. Very good. All right. You guys are on to something here. I think we got a couple more. I did promise these in the last lecture, didn't I?
So we won't have like a difference of like related or assumed equal or unequal for Z, would we? Like that wouldn't be possible.
No, if it's Z,
Yeah.
it's, you're given the population standard deviation, so that's how you know it's Z.
Yeah.
But here you're using the sample standard deviations, but then you gotta figure out which T am I using? Assumed equal or assumed unequal? You gotta look for those words, and if there's no words at all, once you realize you got the sample standard deviations and there's no words at all, you gotta assume it's unequal variances. You gotta go with this one, you guys. Remember that?
So most of the time, we're gonna have to find the right out hypothesis, right?
Most of the time, you're probably gonna have to write out the hypothesis. Should we go back over these and write out hypothesis too? Wow, we just took today's short lecture to much longer. All right, let's do that. So, hang on.
Wait, what's the last
Let's
one?
start with this one right here. Did we read this one yet? No, we
No.
did. You ready? First, let's figure out if it's 1, 2, 3, 4, 5, and then we'll go ahead and put some hypothesis on it. A phone manufacturer wants to compete, excuse me. A phone manufacturer wants to compete in the touchscreen phone market. Management understands that the leading product has less than desirable battery life, so they look for the competitor's weak part. This is good about business right here, because that's what you do in real business. You look for your competitor's weak when you get into a new market. Who's got the largest market share? What's their weak point? And then you go after that weak point by making your product superior in that particular area. So they aim to complete the new touchscreen phone that is guaranteed to have a better battery life more than 2 hours longer than the leading product. Stop there, one tail or two tail. They're promising, I want to read this again. They aim to compete with a new touchscreen phone that is guaranteed to have a battery life more than 2 hours longer than the leading product. One tail or two tail? One tail, more than. That was the key word there, more than. A recent sample of 120 units of the leading product provides a mean battery life of 5 hours and 40 minutes with a standard deviation of 30 minutes. So right now I'm asking you, does the standard deviation come from the population or does it come from the sample? You should be saying yourself. A similar analysis of 100 units of the other phone, their new product that they're going to compete with, that they're going to use to compete, results in a mean battery life of 8 hours and 5 minutes and a standard deviation of 55 minutes. Use the p-value approach at 5% significance to determine. It says 1, 2, 3, 4, or 5.
3, 4.
Whoa. All right, we're at that point now, since the first one, that we've gotten more than one answer here. So, someone said 2, 3, someone said 4, I can't remember. Say 2, what was it, 3 or 4?
3.
3 or 4. 3 or 4 is correct. It's either 3 or 4. Which is it?
3.
It is 3. These are not related because one phone's manufactured by one company, the other phone's manufactured by this company who wants to go after that other phone. There's no way these are the same, coming from the same thing. They're not related.
Why is it unequal?
Unequal because nothing in there says that the population variances are equal or that the population standard deviations are equal. And if it doesn't say it anywhere, you got to assume they're unequal. It will definitely tell you if they are equal, but if they're not equal, sometimes it will tell you they're unequal, but most of the time it won't tell you anything, and you got to assume they're unequal. I think I got one more. Let me check. Here we go. Do women really spend more money on shopping as compared to men?
Wait, which one was it?
Wow. Wow. I hesitate doing this question. It does sound kind of. What's the word I'm looking for? Sexist, thank you, that's the word I was looking for. It does, a little bit. But these guys' voices I heard seem to agree with it in one sentence. It doesn't even make sense to me. Because none of us should be spending it all. You gotta realize, what's the difference between a want and a need? Food, you need, right? Brand new car, that's a want. Satisfy your needs, not your wants. Until all your needs are satisfied and you want to splurge a little, then go to the wants. But focus on the needs and forget about the wants. You don't need to have the wants. Do women really, I don't even want to read that again. A survey found that women spend an average of $43.87, while men spend an average of $34.54 per week. Assume that these data were based on a sample of 50 men and 56 women, and the population standard deviations of spending for men and women are $32 and $25 respectively. specify the competing hypothesis to determine whether women spend more money on shopping as compared to men. One tail or two tail?
3.
One, because more money gives it away. More money gives it away. At 10% significance, state the conclusion using confidence interval approach. 1, 2, 3, 4, or 5? One it is. One it is. And the reason is these are definitely two independent samples, not related in any way, and we were given the population standard deviations, not the sample, so that's how we know it was the top one. Don't forget, from a couple, this was all in one, this was like all 1 week here. Population standard deviation, sample standard deviations. Then this week is that they're related and we're only using sample standard deviations. We're only doing the T. We're skipping the Z. And then next week we're gonna have proportions, which is only Z. There's no T involved. All right, so let's go back now and state this one right here, the hypothesis itself. First of all, it's the first one, so I don't have these memorized as to what's on the left side, what's on the right side, so I'm winging it here. But here's the null, here's the alternative. I know there's some symbol here, I can't remember. What's more important to me right now, is this less than equal, is this greater than equal, is this equal, is this not equal to? That's what I want to figure out from the sentence. I'm going to read it again. Do women, well right here, specify the competing hypothesis to determine whether women spend more money on shopping as compared to men? Less than equal is the alternative? The null. So you're saying the null is less than equal to 0. This would be greater than 0. And let's test this hypothesis. Is women the first sample? Let me see, is the first sample women? It says where's the spending at? Women is at 4387, so that'd be our first sample. Men at 3454, there's our second sample. So it'd be women minus men. So if we take 4387 minus 34, would we be above 0 or below 0? Above 0, and we're trying to prove that women spend more. That's our whole reason for doing this experiment, to see if women do spend more. So that would mean 43 minus 34, that's why our alternative has to be greater than. And our alternative is greater than, the null then would be less than equal. Does everybody see the logic behind coming up with that? Let's do another one.
Wait, why is it 0?
They're all gonna be 0. This whole semester. When there's 2 samples involved, they're all equal to 0, or 0's involved on 2 samples. If they said women spend differently than men, then it would be a 2 tail, and it'd be equal, not equal to. Let's do this other one here. So they're trying to say, they're trying to prove that their battery life is longer for their phones compared to the market shareholder, the competitor. Longer battery life, 1 tail or 2 tails. I think you already told me this. 1 tail. So let's figure this out now. What are the 2 samples? Again, let me just erase this because it's the same thing. Look at these 2 samples. Is the first sample the competitor's battery, or we're the ones making the new phone? We're the ones making the new phone. Did our phones come first, or did the competitors' phones come first in this research? So it says here, let's see, they aim to go that their new phone will be 2 hours longer than the leading competitor in a recent sample of 120 units of the leading competitor's product. So theirs came first. The time's 5 hours and 40 minutes. Think about that. Then in a sample of 100 units of our phone, that's the second one, the time came to 8 hours and 50 minutes. So if you take 5 hours and 40 minutes minus 8 hours and 5 minutes, are you going to get a number above or below 0? Below 0. And you're trying to prove that yours is longer, so you're the alternative hypothesis. So that means this one would be less than 0, and that would be greater than 0. Everybody see the logic how I came up with that though? What is it you're trying to prove as if you're the researcher? What order is the samples in? If you did subtract them, with the result, and it's proving what you're trying to prove, is the alternative going to be greater than or less than 0? Then you know the null is the opposite. All right, let's take this one step farther. You ready? We just rejected the null hypothesis on this phone. We just rejected the null hypothesis, and now we're being told, and you will be told on quiz 3, to write a sentence to put in words what that means. Let me repeat that. You know this is coming, right? So practice this. We just rejected the null hypothesis on the phones, which means the alternative is what we just proved, pretty much. So put in words what we just proved, that something about our phone, we can conclude. Oh, that's as far as you're going? Is that it? What, you expect another student to jump in with the rest? Someone help her, because she has it, but she wants to be shy about it and let others participate. And we can conclude what? That our phones are not better. Our phone's battery life is longer, significantly longer than our competitors at what percent? At 5% significance. That basically saying we have 95% confidence that this experiment proves our phone's battery life is longer than the competitors, significantly longer. You get it? That's what you're gonna put, that's what you gotta get used to. Being able to write the hypothesis, being able to put this in words, as well as design. You guys, from quiz 2, you're proving you haven't figured out how to either reject or not reject the null hypothesis. We now gotta put it all together and turn it into words. What does it mean? Problem? What will happen is the instructions will tell you whether you have to explain or not. There's a couple of problems I already have in my mind, I haven't written down yet, where there isn't a bunch of words. It's not a story, it's just gonna give you some numbers and you gotta calculate, so there's no way you can write a sentence as to what it means. You're just gonna tell me whether to reject or not reject. But you've gotta be prepared to use any approach. It may be the p-value approach, it may be the critical value approach, it may be the confidence interval approach. You gotta be prepared to do any of those. And I'm sorry. You have to include the zero on the hypothesis, yes. When you write a hypothesis, you gotta have that zero involved. And then this could be the mean difference. This could be one mean minus the other mean. You're about to learn how it's gonna be one proportion minus another proportion next week. So these, the left side could be a whole bunch of different things, depending on which one of these 5 you're using, but the right side is only gonna be 0 for this class. Don't be wrong, if we were going on to another class, we would show ones that don't have 0, but almost, in most cases, it's 0 on the right side when you're comparing 2.
Professor, do you have these solved?
Do I have these solved?
Yeah, do you have them on
No.
another document?
No, I just wrote these last night, just so I could do this little experiment here. I think it's paying off. I think you guys are now a little more aware of what you need to look for, right? I think that was the weak spot. Let's look at the homework. Where is our homework here? Is this it? Here we go. In this one, you have 1, 2, 3 problems, manually calculating. Looks like they're all gonna be related samples, because this is the week we're on with related samples. The first one's a two-tail, obviously. Look at how it's just giving you numbers and there's no story. So in this case, you don't have to, you're just telling me whether you reject or not reject the null hypothesis. You're not gonna be giving me a sentence describing what it means because there's no story there to even put it. The second one though, there's a story involved, and I want you to read what's expected here. Use the confidence interval approach. What was the first one, by the way? Was that p-value approach? Again. The first one is use the appropriate equation, manually calculate your value for the tested setting, then give the Excel equation and result to use to calculate the p-value. At 8% significant level, explain using numbers if you can reject or not reject the null hypothesis. So this is all about using p-value, the first one. The second one is all about using confidence interval. Is that what it says? Use the confidence interval approach at 5% significance, which is the same as 95% confidence, don't forget that, to determine if you can reject or not reject the null hypothesis. Give the correct Excel equation involved. Make sure and give a sentence what your conclusion means using words in the description of the problem. The second problem has a story, and after you tell me whether you reject or not reject, there should be a sentence describing what that means using the words from the story like we just talked about. What it means. And then the third one, use the information from the problem above, number 2, and use the critical value approach this time to compare and explain if you reject the null hypothesis or not. You don't have to write that sentence out again, what it means, but you do have to show me a different approach, the critical value approach, and then tell me if you reject or not reject. Does everybody understand the written part of the homework, all 3 problems? All right, now, before we get to the Excel part, I want to practice. I set this up. Are you ready? Where is it? Right here? Here we go. Let me make it bigger. Up here. Okay, this is a hypothetical problem. I'm preparing you for the quiz, but the only thing about the quiz is, if I give you a hypothetical problem like this, I'm asking you to solve it with one approach. I want you to see how I'm solving it with all three approaches. And this is is this related? Yeah, this is related mean. So this is this week, what we studied on Tuesday, related mean, and all three approaches involved. So here's the hypothetical situation. The mean difference is less than or equal to 0. The mean difference is greater than 0. The alternative hypothesis is greater than. So that's really what we're trying to see if that's true or not, that we believe the mean difference between these two samples is greater than. The sample mean difference, 4.2. You're given the mean difference right there. The number of pairs, 36. Notice the word pairs is used. That gives it away right away that it's this one, this fourth one, related samples. Sample standard deviation of the difference. This is the only one that uses the standard deviation of the difference, is related samples. That kind of gives it away also. 12.4, use 4% significance. So I'm going to start with the p-value approach. Tell me what you would calculate if you were attacking this problem with the p-value approach. What would you calculate first? Yes, that's right. No, is that you? Extra, oh, there you go. Almost. Test statistic, there it is. 2.0325, but look how I set it up. I took the sample mean, the mean difference, which is 4.2, over the standard deviation of the difference, 12.4, divided by the square root of the number of pairs. The sample size in pairs is 36. Did all the math on it and got 2.0325. Now, since it's the p-value approach, you're going to use this test statistic number to find the p-value. Equals T dot DIST 2.03225, comma, 35 degrees of freedom. Look at how I got that. There's 36 pairs minus 1. That's how it is on this one. Related samples is however many pairs minus 1 for degrees of freedom. Comma, 1, because it's a one-tail. Look at the hypothesis. Here's our p-value, 0.024886. Look at the p-value. Look at the significance. Do you reject or not reject? Can't hear you. Reject or not reject. Look at the p-value, 0.024886. Look at the significance in the problem.
Reject.
I hear reject. Because our p-value, 0.024886, is less than our significance, 0.04, we can reject. Critical value approach. Do we have enough information to do our critical value? Help me, tell me what I'm going to put there for critical value. Equals, you're told to do the critical value approach. Huh? T, is that it?
Keep going.
T what? IMV, I hear. IMV, parentheses. We're doing this problem right here. Come out. What's going to be in there? What's significant?
Double the
Why double it?
because it's on the
Ah, very good. That's right. So what is the significance? 0.04, double it. Oh wait, comma. Degrees, what's next? Degrees of freedom? Degrees of freedom, which is 35. There we go. You guys, you're gonna run out of time. This, you know, there's a time limit. You gotta be on top of this. There it is, 1.803. Look at our test statistic that we calculated doing the p-value, 2.03225. Our critical value is 1.80. Our test statistic on the number line is outside the critical value, outside, which gives us evidence to reject the null hypothesis. Okay, there's critical value. We're going to do confidence interval. You have all the information to set it up. I want to know you can set this up. Confidence interval, what's the first number to put here?
mean difference.
What is the mean difference?
4.2.
4.2 plus and minus. Now what number should be next? What is it? What's the number? 1.803. Is that 0?
Yeah.
0. Okay, I'll stop there. Times, I'm putting parentheses there. What number's next?
12.4.
What is it? 12.4?
Yeah.
12.4, got it. Then what?
Divided by
Divided by?
36.
square root of 36 you mean? I think you said 2.
No, I said six.
Just checking.
She said 6.
Oh, look at that, people on your side here or something, I don't know what happened just there. All right, there it is. There's the critical value. Confidence interval, you set it up perfect, 1.0830 times 12.4 over the square root of 36. Do all the math of this. Now look at the lower confidence interval, look at the upper confidence interval. What are we trying to figure out? What about those lower and upper interval? What are we looking for?
The zero fit.
Does 0 fit? Does 0 fit?
No.
No. And when 0 doesn't fit, we reject or not reject?
Reject.
Reject. All three of them said reject. All right, you're ready. You're now ready for this next piece of information. I'm on page 361. It's example 10.8. In example 10.8, we decide we're going to use this Excel function called t-test. I'm right here at the top of this picture. Hang on, where's my pointer? How come the pointer's gone? Hang on. Boy, there it is. There it is. There. Right there. See that right there? T-test paired to sample for means. Everybody see that? That's the one we use for related samples. What you need to be familiar with is, if I give you a picture of this, and maybe a picture of a spreadsheet, and I may be asking you, what would you put in the variable 1 range? I need to know what you're going to put in that box. That would be your answer to that question. Looks just like this. That right there, see that 0.05? That's whatever the significance is in the problem. They're not all going to be 0.5. The default is 0.05, but they're not all going to be 0.05. The hypothesized mean difference for this class will always be 0 for 2 samples. So that you can go ahead and put a 0 in there. Then we go ahead and we take this whole sample and we plug it into the output, and here's what we get. Hang on a minute. I'm so colorblind I can't see the pointer. And here's our output. There it is. Look at that output. Oh, is that a good looking output? You ready? I need to know the numbers I'm going to use the critical value approach, one tail critical value approach. Give me a number. Hit me with one of the numbers. One tail critical value. Give me one of the numbers. 1.6489 is the critical one tail value. What do we compare that with? Not all ones? Huh? Which is what? 6.7795. Is our test statistic inside closer to 0 or outside the critical one tail value of 1.6849? Inside or outside? Way outside. It's so far outside that we in no way can accept, but we never say that. Instead we say we must reject it. We must reject it. It's so far outside that critical value. Hang on a minute, we just found out this is a two-tail. And we're going to use p-value. And it's 5% significance. Remember, we looked at the output. There was 0.05 in that box. So this is a two-tail now, p-value. What are we comparing to 5%?
4.3.
Ah, look at that. 4.30, let me write this down. 4.31 E negative 08. On your calculator, that means that really the number is the decimal is 8 places to the left. Negative means the decimal is really to the left, that many places, whatever the number is after it. If that's positive, it'd be decimals to the right. But this is to the left. So I gotta move that decimal 8 places to get the real number. Ready? 0. Let's see, 1, 2, 3, 4, 5, 6, 7, 4, 3, 1. Now let me make sure I moved it. 8 places. 1, 2, 3, 4, 5, 6, 7, 8. I did it. This is our p-value. This is our p-value. My question is, you're comparing that again to what I forgot? 0.05, 5%. Is our p-value less than or greater than 0.05? Far less than. Are we rejecting or not rejecting? Reject. Just like using the critical value, where 6 was so far outside of 1.68 or 2.0227, we're obviously rejecting. This p-value is so much lower than 5%. We could use 1% significance. It's way below 1%, and we're obviously rejecting. Does everybody see how to use this output? Should I go another question on the output? We got it. How many degrees of freedom is this output, say? 39, you got it, because there's 40 pairs minus 1. Notice the first sample has 40, the second sample has 40, because these are related samples. They're the same 40 people or whatever is involved here. Go ahead.
What page is
This is on page 361 in your book, the 4th edition, example 10.8. Matter of fact, it could be the next page, 362. It starts on 361, but I think it goes to 362 for this picture right here. Okay, now, we all have to make this table. But last week's homework prepared us for this, so this is not gonna be hard at all. Where is our example? Right here. Boom. Here it is. You ready? Tell me what to do first. What should I do first? You're gonna make this is a related sample t-test for this data right here. They're related samples. They're from before and after, the same, however many people this is involved, is that many people, before and after something happened, whatever it may be, before 10 drinks, after 10 drinks, who knows, what is this? My question is, what do I do? The instructions say to make a table and then answer a question. What should I do? Oh, okay, data tab, go to data tab, there we go, then what? Data analysis, very good. Then what? Look for that table name. It's called t-test paired to sample means. Do you guys see them? Right there. There it is. T-test paired to sample means. Now when I open this up, we're checking the box for labels. And we're including the labels in our range. Are you ready? So I'm going to click the box. We're clicking labels. We know the hypothesis for the null and alternative hypothesis have to do with 0. So I put a 0 there. Now the range of the first data, I'm gonna click on the title, hold down my left click and drag it so it includes the title and all the data. Now the second variable range, I'm left clicking on the word after the title, holding it down, drag it, get all the data plus the title. There it is. New worksheet, because there's one right here, we can see if we did it right. Okay, so here I go. It's gonna now make the worksheet on a new page. There it is. Let me open it up a little. Hey, Dan, you know that the whole reason why yours could not be seen is because you had the Q so close to the P that it wouldn't open up, you couldn't see the other column? And then, so I kept playing with it, and all of a sudden I got it to open like this, and there was all the other numbers.
Yeah, I made them wider before, and I don't know why when I submitted it closed it, but.
Anyway, so here we go. Did we get the same numbers? I'm gonna go back and forth. Let me get this table up here. Did we get the exact same numbers? Let's start at the top left-hand column. 1407, 3374, 1407, 13.96, 13.96. 0, 12, 2.48, 0, 12. So we got the same numbers. All right. Now let's analyze our output. You ready? Hey, using the critical value approach two-tail, would you reject or not reject the hypothesis? Again, I said use critical value approach two-tail. Tell me the numbers you're looking at. Critical value two-tail is what number? 2.1788. 2.1788. And we're comparing that to what number up there? 2.4828. So think about it now. Is our test statistic inside closer to 0 or outside the critical number 2.1788? Outside, which means we reject or not reject? Reject. Oh, this is too easy now, isn't it? Can everybody make this table? Can everybody analyze the table no matter what the question is? Using critical value, using p-value, right? Do we have enough information there if we wanted to? Let me stare at it for a minute. Nope, I'm not even gonna ask. Make confidence intervals? We don't have enough information there to make confidence intervals, do we? Because we don't have the standard deviation of the differences. We don't have that. Or we'd be able to do this. All right. I think we're ready for our in-class assignment.
Yes.
Yeah, I got the video.